Hello everyone, I am Sorudungana. Today we will be conducting scenario analysis for a company expansion problem. You can find the details of the solution of the problem in my previous video. The link is provided in the description section. And for the scenario analysis, we will be using Monte Carlo method. For the basic understanding of Monte Carlo method, you can visit my previous video. The link of this video is also provided in the description. For conducting a scenario analysis using Monte Carlo method, we must first identify the input parameters, their uncertainties and their distribution followed by those inputs. So in this problem, here I have defined some distribution that are followed by the input parameters that are to be used in the discounted cash flow model. For this, we are assuming that market size will vary as per the uniform distribution with minimum value of 900,000 and maximum value of 1,100,000. Similarly, selling price per ton will vary with triangular distribution with the minimum value of $630 and maximum value of $770. Similarly, market growth rate will vary with most likely value of 3% and it follows triangular distribution with minimum value of 2% and maximum value of 4%. Similarly, market share of the company will vary following triangular distribution with minimum value of 8% and maximum value of 12%. And the estimated useful life of the service will vary with the uniform distribution with minimum value of 8 and maximum value of 11. The residual value of facility will have most likely value of 4 million and it will vary with the normal distribution which has mean of 4 million and standard deviation of 100,000. The last uncertain input is operating cost per ton, which has most likely value of $500 and it follows the triangular distribution with the minimum value of $450 and maximum value of $550. Other all input parameters are kept constant for this analysis. Now let's move forward with the setup of Monte Carlo method. For this, at first all the input parameters must be defined as assumption. For this, the first input parameter market size is selected. It follows uniform distribution, so uniform distribution is selected and the value are minimum 900,000 and 1,100,000 for the maximum. So 900,000 and 1,100,000 is selected in the maximum section. Enter is pressed and for the selling price ton, similarly triangular distribution is selected. The minimum value is $630 and the maximum value is $770. For the market growth rate, triangular distribution is selected. Here the minimum value is 2% and maximum value is 4%. The market share of the company follows the triangular distribution with the minimum value of 8% and the maximum value of 12%. Similarly, the residual value of the facility at the end of the 10th year follows normal distribution with mean of 4 million and standard deviation of 100,000. The last input uncertain variable, operating cost per ton, follows triangular distribution with minimum value of $450 and maximum value of $550. Here all the uncertain input parameters are defined. Now we must define the output. Here two outputs are selected, NPV and IRR. Now for the solution of the problem, 10,000 iterations are selected and solution is run. Here we have obtained two charts for NPV and IRR. In our problem, the minimum attractive rate of return is 12%. Now let's see what is the certainty of IRR becoming more than 12%. The certainty of IRR of being above 12% is around 57.78%. and whenever the NPV is positive, that is greater than 0, the project is acceptable. Here the certainty of positive NPV is 60.16%. In this way, we can analyze the risk associated in any project by using Monte Carlo method whenever the input parameters are uncertain. Thank you.